All right, so in this video, I'm going through pages 10 and 11, the practice. For page 10, it's just using our calculator to solve matrices. So first, I'm going to create the matrix that I want to represent this equation. That's going to be 7, 2, negative 19, negative 1, 2, and 21. All right. And then based on that, we want to go over to our calculator, go to our matrix. I'm going to do this in matrix 2. It needs to be a 2 by 3. Put in my numbers, so 7, 2, negative 19. 7, 2, negative 19. Negative 1, 2, 21. Negative 1, 2, 21. All right. And then we can back out of there, go back into our matrix menu, again, go over and go down to, second matrix, math, go down to RREF, second matrix we put our numbers into. Now we can see that the result, 1, 0, 0, 1, negative 5 and 8, meaning that our solution to the system is x is equal to negative 5, y is equal to 8, which we can write as an ordered pair as negative 5, comma 8. All right, now I'm going to do the same thing here, but now with a system with 3 variables in it. So I can go negative 2, 2, 1, 14. 3, negative 2, 1, negative 5, negative 1, 1, negative 2, negative 8. All right, I just need to plug that into the calculator here. Second matrix, I'm going to go and edit. I'll use matrix 1 since it's already the right dimensions. So we have negative 2, 2, 1, 14. 3, negative 2, 1, negative 5. And I have negative 1, 1, negative 2, negative 8. So negative 1, 1, negative 2, negative 8. All right, and then we can go matrix, math, RREF, second matrix, matrix A, press enter. We can see that our solutions are negative 3, 1, and 6. So give me 1, 0, 0, 0, 1, 0, 1, 0, 0, 0, 1, 6. That means x is equal to negative 3, y is equal to 1, z is equal to 6, which I can write as a coordinate pair like that. All right, now we can do the same thing down here. We can go back to matrix, edit, go here this time, enter, enter. We got 5, 1.25, negative 2.5, 1.25, negative 2.5, negative 0.7, 2, and 5.6. Okay. Second matrix, math, RREF, second, so we want to quit out of there. Second matrix, math. Second matrix, math. To RREF, enter. Oh, sorry about that. I don't know how to mute my mic without stopping the video. Anyway, carrying on. RREF, now we can see our answers there. If we look at it, it wants our answers to 3 significant figures as an ordered pair. So we can do negative 1.10, so negative 1.10, comma 2.41, which we can round to 1 decimal place as negative 1.1, comma 2.4. All right. So this is where it starts to get interesting. Now on page 11, here we're not given a system. We first have to construct a system. So it says, given quadratic function, f of x is equal to ax squared plus bx with the following shown points. There, and then 2t. Use the points above to write down 2 equations in terms of a and b. Well, so what we know is that when x is negative 1, f of x is negative 4. So what that means is f of negative 1 is equal to a times negative 1 squared plus b times negative 1. We know that that is equal to 4. And we know that f of 1 is equal to a times 1 squared plus b times 1, and that's equal to 8. So if we clean that up a little bit, negative 1 squared is 1, so that's just going to be a minus b, because b times negative 1 is minus b, equals 4. And then we have a plus b is equal to 8. Remember, 1 squared is 1, 1 times a is 1. So now we have this system here. And we can go ahead and solve that system using our calculator if we wanted to. I actually think in this case elimination would be faster, so I'm just going to do elimination. I'm going to notice that a and a have the same coefficient, so we can, or actually I'm going to notice that negative b and b have opposite coefficients, so I'm just going to add these equations. And I'm going to get that 2a is equal to 12, meaning that a has to be equal to 6. And if a is equal to 6, then a plus b being 8 means that b has to be equal to 2. And if a is 6 and b is 2, then that means that my equation f of x is equal to 6x squared plus 2x. And that means that f of 2 is equal to t. So first of all, a is 6, b is 2. F of 2 is equal to 6 times 2 squared plus 2 times 2. That's going to be equal to 6 times 4, which is 24, plus 4, t would be 28. All right. And down here, once again, we need to construct a system. So we have Jaquez is buying 6 CDs and 3 video cassettes for $163.17. You can also buy 9 CDs and 2 video cassettes for $253. All right, so let's let X be CDs, number of CDs, and let's let Y be number of video cassettes. Then based on our first video, I can write that a little bit neater maybe, cassettes. All right. And then based on the first bit of information here, 6 CDs, well, that's 6X with 3 video cassettes, so that's 3Y, is a total of 163.17. And then 9 CDs plus 2 video cassettes is 200.53. And for this one, I'm just going to do that using our matrix. So I'm going to use this matrix. I'm going to say 6, 3, 163.17, 9, 2, 200.53. And then I'm going to plug those into my calculator. So matrix, we'll edit, we'll use B because it's the right size. And then we'll say 6, 3, 163.17. Looking at the second row, it's 9,200.53. So 9,200.53. Okay. You can go second matrix, math, RREF, enter. Nope, sorry, so we want to back out of there first. Second math, nope, second matrix, math, RREF, second matrix, B, press enter. So you can see that X equals 18.35. Y is equal to 17.69, which means that one video cassette is the price of Y, so that is $17.69. Perfect.